Hello, வணக்கம். I am Sujit. Welcome to Physics 2020. So, in this section, we are going to study the theory of that is the projectile motion in an inclined plane. So, in the previous section, we have discussed that is the projectile motion in an inclined plane. So, how the projectile motion, that is, what are the component vectors of that is projectile motion in an inclined plane we have discussed. Okay, so let me continue my discussion in the that is inclined plane. So, so today in this class we are going to derive the expression for that is time of flight, horizontal range and maximum height attained by the projectile in the inclined plane. Okay. So it is an inclined plane. Okay. So which makes an angle theta theta. So this is our x-axis. Okay, x-axis. This is our y-axis. Okay, y-axis. So an object is projected from here at an angle alpha with the x-axis. So it makes a trajectory like this. Okay, trajectory. So with an initial velocity u, okay, initial velocity u. So this is the x-axis and this is the y-axis. Okay. So what is the initial horizontal velocity? So it is acting in this direction, that is u cos alpha, and initial vertical velocity is acting in this direction, that is u sin alpha. U sin alpha. Okay. So what about g? So g is acting in this direction. Okay. So what is the perpendicular to this axis, x-axis? This is the perpendicular. So this angle is theta, this angle is 90 degree. So this angle is 90 minus theta. So definitely this angle is theta. Okay. So this component, that is g cos theta. So and this component, that is g sin theta. Okay, g sin theta. So I can write this is, that is g sin theta. So these are the that is component vectors of what? Component vectors of projectile motion. Okay, so that is projectile motion of inclined plane. Okay, inclined plane. So this is g and this is g cos theta. G cos theta. Okay. So when we draw the diagram for the component vectors, so it is our y-axis and this is the x-axis. Okay, x-axis and y-axis. Y-axis. So projectile is projected from here with the initial velocity u. The initial velocity u at an angle alpha with the x-axis. So the horizontal initial horizontal velocity, that is u cos alpha, and this is u sin alpha. Okay, u sin alpha. So G is acting, the vertical G is acting in this direction, okay, that is G cos theta, and horizontal G is acting in this direction, that is minus G sin theta, okay, G sin theta. G sin theta. Okay, so these are the component vectors of, that is projection in an inclined plane. Okay, projection in an inclined plane. So we have to derive the expression for what? Time of flight. 1. Time of flight. 2. That is maximum height. 3. It is horizontal range. Horizontal range. Okay. So as we already learned, that is the projectile motion. Okay, projectile motion is the combined effect of two types of motion, that is horizontal motion as well as vertical motion. Okay, horizontal motion and vertical motion. So I am considering, that is the vertical motion only. Okay, vertical motion. Vertical motion. So that is the motion along y-axis. Motion along y-axis. So I am using the kinematic equation, that is S is equal to ut plus half at square. Okay, at square. So I am rewriting this equation, that is Sy is equal to uy. Okay, uy. So here t is the time of flight. So I am capital T plus half. It is ay into capital T square. Okay, capital T square. Okay, so what is Sy? That is, so when we consider the vertical motion only, okay, vertical motion only, the displacement, that is the projectile starts from here and it reaches the, so it reaches, that is starts from x-axis and it reaches the same x-axis. So what is the displacement, vertical displacement of the projectile? So that is Sy is equal to 0. Okay, 0. So displacement means the distance between initial point and start point, that is the initial point and the final point. So the initial point is from x-axis and the final point is also in x-axis. So the vertical displacement is equal to 0. So uy, so the velocity in the vertical direction, that is u sin alpha. Okay, so ay, acceleration in the vertical direction, ay is equal to, that is this one, that is minus g cos theta. Okay, minus g cos theta, and capital T, that is the time of flight, we have to find that. Okay, capital T. So substitute the equation, that is substitute the values. So 0 is equal to uy, that is u sin alpha into capital T plus half into, so what is ay, that is minus g cos theta into t square, okay, t square. So when you bring this term, that is we can write that is 0 is equal to u sin alpha into t minus half g cos theta into t square, okay, into t square. T square. So we can write that is when you bring this term on that side, that is positive, okay, that is half g cos theta into t square is equal to, that is u sin alpha into t. So this t and this t cancel. So from this t is equal to cross multiply, that is 2u sin alpha divided by g cos theta. So this is the expression for time of flight. T is equal to yes, t is equal to 2u sin alpha divided by g cos theta. Clear? So when this equation has the resemblance with, that is the time of flight with the projectile motion, that is horizontal motion. So what is the time of flight? So time of flight, that is t is equal to 2u sin theta divided by g. So here that is u sin alpha is the horizontal, so vertical velocity, initial vertical velocity. In there, that is u sin theta is the initial vertical velocity. So there, that is the theta is the angle of projection. Here alpha is the angle of projection. So t is equal to 2u sin theta. So already we have derived, that is in physics 2020, you can watch those videos. That is the projectile motion, that is horizontal projectile motion and motion at a certain height, okay, certain height. So we have discussed the theory as well as the numericals, okay. So if you want, you can go and watch, okay. So if you want to learn that is the fundamentals of projectile motion, means you can watch those videos. So t is equal to 2u sin alpha divided by g cos theta. So here u sin theta is the initial vertical velocity, g is the vertical acceleration. So here 2u sin alpha, u sin alpha is the initial vertical velocity, g cos theta is the vertical acceleration. So from here, that is g cos theta. Here not g is not the vertical acceleration, g cos theta is the vertical acceleration. Clear? So the next is maximum height attained by the projectile. So from this, from point the projectile is projected. Okay. So projectile is projected with initial velocity u. So at this point, that is the projectile reaches its maximum height. Okay, maximum height. So from that point onwards, that is the height decreases. Okay, height decreases. So when it reaches the maximum height, okay, maximum height, so the velocity, that is the vertical velocity of the projectile is 0, okay, 0. So again, that is, this is h max, okay, h max. So we are considering the vertical motion. Vertical motion. So that is the motion along y-axis. Okay. Come on. So I am using the equation, that is v square is equal to u square plus 2as. So I am rewriting this equation, that is vy square is equal to uy square plus 2ay into sy. Into sy. So what is Vy? It is the final vertical velocity. When the projectile reaches at this point, okay, at this point, so the final velocity is equal to 0. Okay, final velocity Vy is equal to 0. Uy. Uy is equal to, it is initial vertical velocity, that is u sin alpha. Ay, vertical acceleration, Ay is equal to minus g cos theta. Okay, Sy, that is the displacement. Okay, displacement. When the projectile reaches at this point, so that is the displacement. So Sy is equal to h max. H max. So substitute, that is Vy is equal to 0 is equal to Uy, that is u square sin square alpha plus 2 into minus g cos theta into Sy, that is h max. So that's equal to 0 is equal to u square sin square alpha minus 2g cos theta into h max. Okay, h max. Okay, so you bring that term, that is minus, when it comes down this side, that is plus. Okay, so 2g cos theta into h max equal to u square sin square alpha. Okay, sin square alpha. So from this, h max equal to u square sin square alpha divided by 2g cos theta. Okay, cos theta. So this is the expression for that is maximum height, u square sin square alpha divided by 2g cos theta. So compare this equation with the maximum height of the horizontal projection. So h max equal to u square sin square theta divided by 2g. Okay, divided by 2g. So sin square u sin theta is the initial vertical velocity, u square sin square theta. Here u sin alpha is the initial vertical velocity, so u square sin square alpha divided by 2g. G is that is perpendicular, that is vertical acceleration. So here 2g cos theta, g cos theta is the vertical acceleration. So there is a strong resemblance between these two equations. Okay, so this gives the the maximum height attained by the projectile. Clear? So next we are going to find, that is horizontal range. Okay, horizontal range. So what is horizontal range? That is the horizontal distance traveled by the projectile. Okay, so when this point is projected, that is the projectile reaches this point. So what is the horizontal distance traveled by the projectile? So throughout the motion, okay, throughout the motion, it is a horizontal distance. Okay, so this is the horizontal range. Okay, horizontal range. Clear? So for this I am considering the horizontal motion. Okay, horizontal motion. Horizontal motion, that is motion along the x-axis. Motion along the x-axis. So I am using again the kinematic equation S is equal to ut plus half at square. So Sx equal to uxt plus half ax t square. Okay, t square. So here that is ux equal to, what is ux? Ux equal to, that is u cos alpha. U cos alpha. So otherwise we can write here. So what is u is equal to ux equal to, okay, ux equal to u cos alpha. Okay, cos alpha. So Sx equal to, that is our range. Okay. Ax equal to acceleration in the horizontal direction, g sin theta. So in the negative x-axis, minus g sin theta. So t is equal to time of flight. Okay, t is equal to time of flight. So substitute the values, that is r is equal to, capital R is equal to ux, u cos alpha, okay, u cos alpha into t. What is t? So t is equal to 2u sin alpha, 2u sin alpha divided by g cos theta plus half into, okay, half into ax minus g sin theta into, okay, into t square 4 u square sin square alpha divided by g square cos square theta. Okay, theta. So that's equal to u into u, that is u square, that is 2 u square sin alpha cos alpha divided by g cos theta minus, so this g, one g cancel, 2, okay, minus 2u square sin square alpha into sin theta divided by g cos square theta. Okay, cos square theta. So take the LCM. So g cos square theta is the LCM. G cos square theta. So g cos theta. So g get cancelled. Okay, cos theta. So we can write that is 2 u square sin alpha cos alpha into cos theta minus, okay, minus 2u square sin square alpha into sin theta, So from these two terms we can take that is 2u square sin alpha commonly outside. Okay, 2u square sin alpha. Okay, 2u square sin alpha divided by g cos square theta. G cos square theta. What is remaining? Cos alpha into cos theta minus sin alpha into sin theta. Okay, so that's equal to 2u square sin alpha divided by g cos square theta, cos A cos B minus sin A sin B, that is cos A plus B, that is alpha plus theta. Okay, cos alpha plus theta. So this is the horizontal range. R is equal to. So clear? 2u square sin alpha divided by g cos square theta into cos alpha plus theta. So no need to memorize this equation. Okay, R is equal to. Just know the concept, that is how to find the. So understand the concept, how to derive that is horizontal range. Clear? No need to memorize the formula. So clear, students? So these are the three expressions for that is time of flight, maximum height and horizontal range of that is inclined projection. So time of flight. So T is equal to 2u sin alpha divided by g cos theta. Okay, g cos theta. So that is inclined projection. So what is the time of flight in that is horizontal projection? So T is equal to 2u sin theta divided by g. Okay, g. U sin theta, u sin alpha divided by g, here that is g cos theta. So vertical acceleration g, here vertical acceleration that is g cos theta. So h max equal to, so here what is h max? H max equal to u square sin square theta divided by 2g. So here u square sin square alpha divided by 2g cos theta. Okay, so there is a strong resemblance between these two equations, that is the horizontal projection and inclined projection. So how to find the range, that is horizontal range? Horizontal range means using the equation that is Sx equal to uxt plus half ax t square. Okay, t square. So ux equal to what? U cos alpha ax equal to minus g sin theta. okay, minus the sin theta. Sx equal to, that is r, then t is equal to, that is time of flight. Okay, t is equal to time of flight. So using this concept we can find the horizontal range. Okay, horizontal range. Clear, students?